Today's class it's about gravitational potential energy. I hope that you might be knowing that we are doing chapter 15. Okay, so this chapter it is work and power. Okay, so in the previous class we discussed work done, how work done is calculated, and what is work done actually. Okay, and what is uh, energy, how energy is correlated with work done. So whenever say some work has been done, that also means that a certain amount of energy has been transferred as well, that we discussed in the definition. Okay, anyhow, let's go back to today's class. Today's class is about gravitational potential energy. Are you able to see my screen? My screen is visible? This one? Okay. So what is gravitational potential energy? See, basically, in simple words, what I can say is, if something goes up against the gravity, goes to a higher level, above the ground, then we'll say that it has attained this gravitational potential energy. It has acted against the gravity and it has reached a level above the ground. In physics, we describe gravitational potential energy as the energy stored in an object when work is done in moving the object upwards. Okay, so this is the definition, and the formula is GPE equals mass into gravity into height, that is m into g into h. The picture on the screen as a roller coaster. You see these people who are there on the roller coaster. We'll say that these people have certain amount of GPE. That's because they are above the ground, they are upwards. So when they will fall, they will fall down with a force, because they already have a potential gravitational potential energy. So when they will fall with a force. Okay, so now when they will fall, all those energies which they have, it's going to transfer, it's going to change to some other kind of energy that we'll discuss very shortly, inshallah. Okay, so I hope that you would have understand what GPE is. This GPE can be anywhere. It can be there in a waterfall. How does the water falls from a particular height, from a mountain or a hilltop? How does it fall? We will say, according to physics, that it falls due to its GPE. Okay, and how can we say this, that it falls based on GP? Because it is falling from a certain height, from a certain level of height, it's falling down. Okay, that's why we say that it falls down because of the GPE. It falls with an energy. Now, for example, if someone stands just below the water which is falling up from above the hill, how will that person feel? Will he not get hurt because of the pressure, because of the force of water? Of course he will get hurt because of the force of the water and because of the GPE present inside the water. Okay, so that means it has some force, and that is because of the GPE. Okay, so let's go back to the formula. The formula is GPE equals m into g into h, where GPE is measured in joules, m is measured in kilograms, that is mass. Okay, then g, that is the gravitational field strength, is measured in newtons per kg, and height is measured in meters. Okay, so again, let me remind you, all your working, your answer, your final answer should have all these units. Okay, whatever the values they give you in the question, in the problem, you have to convert it into these units. Okay, so for example, for height they might give you in kilometers, you have to change it into meters. Okay, then you have to apply this in your formula substitution, then you have to simplify to get the final answer. So I hope that you might be knowing about the conversion process, how to convert kilometers into meters. Okay, gravitational potential energy, how do we describe this again with a simple example? This is a simple illustration which gives you an idea how the energy transfers happen. I told you that when the GPE falls, that GPE, that particular energy is converted into some other energy. Okay, so there are four conditions here, four different stages, A, B, C, D, okay, which you have to understand. The first stage, A, okay, this is a stage where the now this is an example of a ball, of a mass, of a certain mass. Okay, see, for example, this ball is above the ground. Okay, it's held above the ground. Okay, when this ball is in this position, we will say that this ball has a GP. Okay, and doesn't have kinetic energy. Okay, so we are learning here in terms of GPE and kinetic energy. Okay, so we will see how these energy they change when the ball falls or stays up. So when it stays up above the ground, we will say that GPE is maximum and kinetic energy is 0. Okay, just remember. And next stage, when the ball is falling, when it is released and when it is falling, we will say that the GPE is decreasing and the kinetic energy is increasing. Okay, then the third stage, when the ball hits the ground, we will say that the GPE is 0. Okay, so you can always remember that when a ball stays on the ground, we will say that the ball doesn't have any GPE at all, it has a 0 GPE. Okay, but whereas we will say that it has kinetic energy. Okay, and then the last stage is when the ball hits the ground, when it completely falls, and when it hits the ground, we will say that the GPE has been converted, has been transferred to heat and sound. Okay, and also what happens is the object, either it breaks up or it deforms. Okay, it doesn't stay in the same state, it disintegrates. Okay, so this is a very important topic which you need to remember, how these energy conversions happen when an object falls from above, when it falls on the ground. Okay, right. So next slide is about a problem. Okay, so this is a very straightforward problem for you to solve. It says calculate the GPE gain when a weightlifter lifts a mass of 120 kg up by 2.5 meters. So you know the formula, it's GPE equals m into g into h. Okay, so what is your m? Your m is 120 kg. Okay, your g is gravity. Gravity is always 10 newtons per kg. You have to use this value to substitute here in the place of g. And then the height is 2.5 meters. Okay, so all the parameters you have here, it's all direct. You don't need to do any substitution, any conversion here. You directly have to substitute and get the final answer. Okay, so the answer is 3000 joules. Okay, so this is how this has to be done, this problem. You don't have to do any conversion if you are not having any values with a different kind of unit. Okay, so let's move on to the next topic, kinetic energy. We just discussed about kinetic energy. So there is a relationship between GPE and KE, that is kinetic energy, that we need to understand and remember. Okay, now kinetic energy, let us see this one in a separate manner. What is kinetic energy? So you have already you have read about kinetic energy. You already know about kinetic energy. You would have studied this in your previous grades: potential energy, kinetic energy, right? So kinetic energy, what it is? It is the energy processed by a body because of its speed and mass. See, kinetic energy can be described as an energy which is inside any moving object. For example, a fan which rotates has a kinetic energy because it's moving. A person who is running has some kinetic energy because he's running, he's moving. Okay, so it's an energy virtue of movement. It is based on movement. Anything which moves has kinetic energy. This is how we have to understand it in a basic way. Okay, whereas in physics you have to remember this statement: kinetic energy is the energy possessed by a body because of its because of its speed and mass. So this is the formula of kinetic energy. Kinetic energy equals half into mass into speed square. K into half into m into v square, where K is measured in joules, m is measured, mass is measured in kilograms, v, the speed, is measured in meter per second. Clear? So this is the formula and these are the values. Okay, and these are the units which you need to take care while doing problems. Okay, let's move on to our first question based on kinetic energy. The question says, calculate the kinetic energy of a car of mass 1000 kg moving at 5 meter per second. Okay, so you have to apply the same formula, half into m into v square. So what is mass here? Mass is this 1000 kg. You need to put it directly here, substitute this here. And what is your speed? Your speed is 5 meters per second. So substitute the value here, simplify, you get the final answer. Okay, so your final answer is 12,500 joules. Okay, so our next question, it says, calculate the kinetic energy of an apple of mass 200 grams moving at 12 meter per second. Okay, so again the same formula, substitute the values. Here it's 200 kg. Okay, so here you have to convert. Okay, that is, you have to convert this 200 grams into 0.200 or 0.200 kg. Okay, the speed is the same, you don't have to convert anything, substitute here, then you get the final answer. So the final answer is kinetic energy equals 14.4 joules. Sometimes you can also be asked about the speed of the car, so you have to rearrange the formula here. Okay, you just have to rearrange the formula. You have to bring v square on the other side. Okay, when you bring the v square on the other side, you have to take care of the square root. Okay, so this is how you do it. You directly substitute all those values directly here. There is no need for any conversion. Okay, you have to rearrange the formula, and finally when you simplify, right, you have to take care about the speed square. So when you are going to transfer this square over this side, the other side, you have to make it as a root. Okay, you have to make it as a root, then finally you get your answer. Okay, so I hope you would have understood this topic of kinetic energy. Now this is your homework. Better take a screenshot, or later when you run the slides, or when you run this video which I am going to send you through Google Classroom. Okay, you have to use these questions. This is your homework for today. Okay, you have to complete all these 4 questions. I hope that these questions will be easy enough. Okay, any doubts you have, girls? See, power is a measurement of how quickly work is done. Okay, so see, in simple, terms, in simple words, we can say that, for example, a person, he is able to climb up the stairs in a very quick way. Okay, when this happens, we will say that this person has more power. Okay, we'll say that this person has more power, whereas the other person, the second person, he walks up, that is, he climbs up the stair, and that is, he is slower than the other one, he is slower than the first one. Then we will say that this person, the second person, has less power when compared to the first person. Okay, so this is what is power is. Okay, so the power is a measurement of how quickly the work is done. Okay, so the formula is power equals work done over time taken. Okay, so P equals W by T, whereas P is the power, W is the work done, T is the time. Okay, so the power is measured in watts, WATTS. Work done, W, is measured in joules, time T is measured in seconds. Okay, so don't confuse this watts with volts. This is WATTS, whereas the other one is volts, VOLTS, that deals with voltage. This one deals with power. Okay, so both are different, you don't have to confuse these. Okay, right, so directly let's jump on to the formula, sorry, the problem. So how to measure a person's power? Like I told you before, one best way to measure a person's power is asking him to climb up the stairs. The more faster he climbs the stairs, the more power he has. This is what we will say. Okay, the more faster a person climbs the stair, okay, we will say the more the more power the person has. Okay, as simple as that. Okay, so first what you need to do is you need to measure the weight of the person. You need to measure the weight of the person, number one. Okay, that you will do it by using the weighing scales or weight machine, whatever it is. Number two step is you need to measure the time taken for the person to run up, okay, a flight of stairs. That is, you need to measure the time taken for that particular person, okay, to run up the flight of the stairs of height. Okay, then finally you can calculate the work done. The work done can be calculated using this formula, weight into height. Okay, so you know the person, if you know the person's weight and if you know the height of the stairs, for example, there are, these many stairs, for example, there are 6 stairs, so then you have to measure the height of each step, then you have to multiply that with 6, then you get the height of the stairs, because one single value, that is height of one single stair, is not the height of the entire stairs, so you have to multiply with the rest of the stairs. Okay, so if you do this, you get the answer, that is, you'll get the measurement of a person's power. Okay, this W multiplies N into S. N is the number of stairs and S is the measurement of a particular, that is, of a single, it's the height of a single stair. Okay, so it is nothing but that. Okay, so this is how you get the power of the person. Okay, the power of the person you get by doing the work done divided by time taken finally. Okay, right, so first you need to find out the work done, then you need to find the power of the person using this formula. Okay, right, so this is an example calculation. So the weight of the person is 800 newtons. Okay, so this is what we need, the first step. time taken for the person to, you know, to climb one particular stair is 3.0 seconds. How many stairs are there? There are 12 stairs. So we will multiply this with the height of the step. Okay, the height of the step is 0.20 meters. Okay, so we'll multiply this total height of the stair, height 12 multiplied by 0.20 gives 2.4 meters. Okay, now our third step is calculating the work done. We know the weight and we know the height, so we multiply this with this, so we get this value. Okay, 19,020 joules. So the final answer, the power of the person is this divided, that is work divided by the time taken. Okay, so this is the final answer. Okay, so this is how we'll calculate the power of the person. Okay, you have any doubts, you can directly you can ask me. Shifa says I'm not able to see the screen. I don't know why. Others, they don't have any problem as such. Okay, anyhow, I am putting the video online. Don't worry. You'll be able to again watch the video. Any other doubts, girls?